Welcome to this panel discussion for Science Week 2022. Today we have an interesting group of researchers from KTH belonging to the Industrial Analytics and Strategic Maintenance Research Group. My name is Sarah. I'm a student at KTH and also a student ambassador for the Industrial Transformation Platform, and today I will be the moderator for this panel. Here we have Andreas, Robert, Eleonora, Bernd and Mahesh, and I will now give them the opportunity to introduce themselves a bit more.
My name is Andreas Akenti. I'm a professor in industrial dependability, focusing on precision aspects and metrology aspects combined with analytics.
My name is Robert Tomkowski. I'm a senior researcher working in precision engineering and metrology, focusing on functionalization of the surfaces.
My name is Eleonora Yunusova, and I'm a PhD student of Andreas Akenti, and I'm working in industrial analytics for advanced machinery topic.
Hey, I'm Bernd Peukert. I work on process-machine interaction. I'm currently postdoc at the group.
And my name is Mahesh Gopalakrishnan. I'm a researcher in data-driven decision-making for strategic maintenance. Thank you.
Thanks, everybody. Welcome again to this panel discussion. I would like to start by asking Andreas. Your research group is called Industrial Analytics and Strategic Maintenance. What does that mean?
Yeah, basically it means that in order to address the global challenges that we have in the environment today, we need to combine different fields, basically. And we see also that on the systemic level, it's a typical research topic where you combine different things together. In our specific field, we combine industrial analytics that are the tool to do advanced analytics on different data streams, etc., combined with physics and connecting it to strategic maintenance activities. That means that we will cover from the physics, basically the lower level of an organization, up to the top level, basically where the decision for, let's say, strategic actions are made.
Okay, and what impact does it have for the Swedish industries?
So basically what we are working on and have been working on for a while is to develop strategies and methodologies how to assess the capability of systems. And the capability of systems is typically how capable they are to produce a certain part or to produce energy. In our case, we focus a lot of component manufacturing. And one impact where we are looking at is to combine knowledge around the capability connected to quality aspect as well as to maintenance aspect of the systems, basically.
Robert, can you connect to this?
Yes, well, from the precision engineering side, I would say that major failures which is happening in the machinery is caused by surfaces. So I'm one of the link in the group. As an example is when we have a lot of tension of the surfaces, we can cause the cracks. And the main reason of failure is the wear of the components. So that's why the work around the surface is so important, because it's so connected to the maintenance and the work that industrial analytics is here done.
Mahesh?
Yeah, my work in this group is slightly on a parallel level, I would say, or alternative level, I would say. That's because you work, the rest of the group works with components and machine tools and analytics on those levels. And my work comes slightly on the operationalization of decision-making level. So I work with the machines and not necessarily the failures of the machines in terms of specific machines, but work with how to optimize maintenance planning of the whole factory rather. So that is how I complement the rest of the work happening in this group.
Okay. Bernd, why should we still bother with physics-based modeling in a world full of data?
Yeah, I mean, there are multiple reasons, I would say. So AI is very powerful. I mean, we all have heard about its almost unnatural superhuman powers, but it needs a lot of data, and it is especially difficult to interpret. So whenever we build a model, we can just say it's working so good on our training data set and on our validation data set. So there's a big problem in building confidence in the results which you can get from AI. And the beauty in analytics, although maybe the audience doesn't like so much variables and differential equations, is that we know exactly what a variable actually means. So if you put an A somewhere, we know A is that. So in that sense, it gives us a lot of insight in how one physical property relates to something else. So physics-based modeling is something we will do for a long time, I guess, still. And I think the most, let's say, recent work is going towards hybrid models. Also, Eleonora is working on them, is how to inform physics, how to inform machine learning with physics to make it more physical, like viable. Maybe you can say some words about it.
Yeah, exactly. We would like to trust our models, and without implementing the physics knowledge, our models are not trustable and not traceable, and the domain knowledge is the foundation for creating the upper level of AI models, I would say. And Andreas probably can explain us why is the domain knowledge is so important, and what exactly which type of knowledge we count as a domain knowledge.
I mean, domain knowledge in general is a knowledge around a specific field, basically. And if we look at what we are working on, domain knowledge can be, for instance, how a certain machinery works, or knowledge of how to design a certain machinery or to run it. And an example, for instance, if we take an industrial robot or machine tool, it's a knowledge how different joints is functionally working, how, for instance, a wear mechanism is acting on those joints, and combine that with other domain knowledges in order to get this systematic approach, what we talked about initially as well. So domain knowledge, I think, is a key element here to be able to do this physics-based approach, what we are dealing a lot in our team.
Yeah.
I would like to add actually to the domain knowledge discussion, because that's very important for maintenance planning on a factory level as well. If you strictly look at the data from machines for us on a factory level are boxes that data comes out, but we don't really know about the nature of the machine, the type of production that it is ongoing, and the type of variance that takes place in those machines and so forth. So when I talk about domain knowledge on a factory level, then I'm talking about the production planning, not necessarily just the maintenance plans. The production planning, the product variance, the demand, the buffers that are available between the machines. So everything contributes to the flow of production. So having those knowledge combined with the data analytics on factory level really helps to plan maintenance for these machines in a really, really effective way. So that will definitely lead towards reduction of failures for sure, but also it will help in increasing the throughput of the production system.
Oh yeah, that's maybe one of the other half of the answer for why is physics-based modeling so important. So just to get back to that is, what we don't want to do is we don't want to run expensive experiments. And AI needs expensive experiments. So whatever we can do beforehand is actually just saving a lot of money in the form of personal resources and also material resources. So usually we're dealing with machining tasks. So especially if you're manufacturing something very fancy, it takes a while. So whatever we can model beforehand is a gain.
I think that's very interesting. Now, going back also to what you said, Mash, I mean, this is also an example on where we are linking the physics in our organization all the way up to the decision making, because when it all comes around, it's the decision we have to do at various levels in a company or an enterprise. And in order to take good decisions, so to speak, we need to include all these levels, basically. And that's the beauty of this type of approaches. Yeah.
But also that give us the opportunity to collaborate across domains, actually, because this is not that it's specific to one domain knowledge. And it requires very tight collaboration between different domains. Otherwise, it will not happen. So we start from the measurement side, when the methodology applied for the, getting the data from the production that will be analyzed somehow by algorithms. It's making the sense of physical world, and at the end we will have some decision making. So this is like a perfect combination of the collaboration platform.
And as a data scientist, I would like to say that I'm very glad to be in this team, because of before, like the general, the general way to work with AI is usually you collect a lot of data and you predict something, and you have no connection to anything what happening before the collecting the data. You have no idea what this data contains, what this data means. You do all this AI magic, and then you just try to predict something. But the prediction itself is not the final goal. Our final goal is actually the make decisions which are important for the company. So I'm glad to be now in this flow, to know actually a bit earlier what's happening earlier than doing this fancy data analysis work, and then to actually see that it's make some changes in the company.
Giving some meaning
Yes,
to the
exactly.
data.
Yes.
That sounds great. Mahesh, what is data-driven decision making? Why is it so important for Swedish industries?
Great question. It is really, really important. If you're talking about manufacturing companies, what we're really dealing about is a lot of uncertainties. It's a complex environment. The machines are complex. The processes are complex. The people are always, of course, complex. And then we put all of these things together in one building, so to say. And we expect really, really great products at a really fast pace and a high quality. And that's going to be hard. And we need to reduce the uncertainty as much as possible. And this is where I think data-driven decision-making comes into place. We are in a time in this world where data is everywhere. But what do we do with the data? That's where we really have to be smart and be standing out with the way that we use data. So a smart way to work with reducing uncertainties is collect the right data, use it for right decision making, do better predictions, as Eleonora said, and then make decisions. Not do decisions based on what we knew yesterday, or not do decisions based on what could be, but rather have good predictions with high level of certainty so that you could make the most out of what you have. And then we can aim for higher productivity and quality and sustainability.
I would like to add to that, because this is a very important topic, and we address that also as a new course for the students, which is also important, I think. We have decision making for advanced manufacturing, because we see that it's not only what is happening on the manufacturing floor, but also we have to educate the new generation of the students to tackle these problems about data-driven decision making, which is not easy, because we collect a lot of the data and we would like to make a meaning of this and have really data-driven decision, not just assumptions, not emotional decisions, or because we don't know something. So that's why we have a new course.
And that's so important also to get the mindset there from beginning.
Yes.
Also when you are
Absolutely.
new baked engineer, so to speak, that you have it already in mind that you're not. It's not only a small area that we are focusing on. Actually, it's the system again,
Yeah.
and we are talking about decision at various levels, and have that based on
Exactly.
facts and information that we can gather, or group of information that we can join and fuse.
I think the mindset aspect is also super important to realize. Industries nowadays, especially manufacturing companies, they do have a lot of data. And just because we put an AI algorithm or a nice software doesn't change so much. It might use the data to give predictions, but the people in the industry needs to be always aware of what is that they're predicting, what is the data that they're using for what type of decision making. And it also adds to the domain knowledge thinking as well that we discussed about a bit more earlier. So what I'm trying to get here is the AI algorithms and data does the work, but it doesn't mean that's the end of it. We need to have a shift in our thinking on how we apply this and how we use this. And that is when it will really get us far in terms of real data-driven decision making, I think.
And the problem with machine learning and AI algorithms is that they usually not generalize well. So you can train the model only in one machine, and then you cannot be sure that it will give you the same accuracy and so on in another machine, even in the same type of machine. If they are working in different environments, they can have completely different behavior, and we need to retrain model. And in most of the cases, we can predict the failures which we already saw, which we were trained on. That is also a huge problem when you just try to apply the algorithms to the data without taking into account the physics-based.
It's also the big problem with building a trust for this type of analysis. I think it's one important factor, and this is what is happening on the industry right now.
Exactly.
So we have a vast amount of the data. We apply different algorithms, machine learning, and so on. We give some meaning. We try to make a decision making, but at the end of the day, can we trust this algorithm? So it's building a trust around this new technology that is you're working mostly on is super important, and it's also the part of the mindset.
Yeah, because this is how do we build trust. I mean, if you look at a classic field where we are talking about high levels of precision, is the classic field of metrology. And in metrology, we usually have three parts there. We have the uncertainty, we have the calibration, and some sort of artifact and traceability. And that is what we also try in our team to fuse together within this domain of data, I mean, machine learning and data science as well. So we get the traceability through the things we are doing as much as possible. In some cases, it's not possible, but in many cases, it's possible to have that. For instance, what do we measure? When do we measure it? How do we measure it? What does the data represent by looking at it as a starting point? And I think that is where we start to build already there the trust in these situations. So yeah, I think this is very interesting.
It's very nice to say. You said that it's a lot of planning in that. I think we discussed that lately with students also, that planning what data will be collected is super important. To not over collect the data, so identify the elements that need to be collected. Otherwise, we will be just in the noise of the data, and this is not the part we want to do. So this is also an important part of the work, to plan which data I want to have, not just pick them randomly or take them all, because that doesn't work either.
Exactly. Yeah.
Yes.
Which data and where this data should be collected from, because of the placement of the sensors, it's also very important.
Yes.
Exactly. Yeah.
Exactly.
Bernd, can you connect to this?
Yeah, definitely. Of course. I mean, maybe just to circle it up, maybe I think it's one of the beauties of our team is that we are combining like coming from a history where we did this machine tool characterization or production system characterization, because Eleonora just touched the problem that every machine is different, right? So every machine has its, we call it fingerprint. And we are these days not looking so much into it anymore, but we have a long history in looking into how things are different, and then try to extrapolate these differences in a way that we can then, so to say, guess the differences in those models beforehand. So again, the physics-based model it's at the center, I would say. As long as we have a good model of the machine and we know somehow what's going on, we can extrapolate to those uncertainties, to those unknown quantities. So in that sense, I think we are a very good match, actually.
And we can actually set a value on the uncertainties also.
Yeah.
That's important. How certain are we on a certain thing, or how uncertain we are? And that is very important to state. When
Now we sound maybe very nerdy. but when we say this, I mean, it's really a lot of money we're talking about. Like if there's a wrong decision somewhere made, it costs millions of kroners.
Yeah.
That's exactly correct, I think. The thing that we don't see from the way that we talk is the amount of money involved here. In terms of direct losses in costs, but losses in production, losses in quality, which will lead to losses in demand for certain companies as well. So it's got a lot of rippling effects, and that could lead to catastrophic problems if not taken seriously.
One thing to add to that is not taking the decision is also very costly, because it's stopping the progress and development, and can cause other problems and stop the flow of the production, and definitely lost a lot of money. So
but how can manufacturing companies use your research?
So we usually collaborate with the industry and society through projects. We have research projects rolling all the time, and for instance, we have projects rolling around texturing of surfaces to understand how that affects the system capability. We have project working on industrial analytics. We have a project, for instance, called IAM, Industrial Analytics of Advanced Manufacturing. And in that project, for instance, we are looking on how, for instance, data should be sampled and recorded from the machine, how to use it to draw deeper conclusions about system behaviors and so on. And also linking it to the capability of, let's say, a guideway or a ball screw, if we talk about more detailed information about the system as well. And I think we have some example also from the team that are involved in that project as an example. Beside project, of course, we also have educational activities, courses and so on at university level, as well as courses directly to industry as well, through this lifelong learning or livslångt lärande, as we have it as well. But I think project-wise is the most, the one that we're most working with when we're relating to industrial collaboration and so on. And talking about this IAM project that I mentioned about, there we, as I said, look at, once again, the capability of systems, and we break it down to single subsystems. And if we talk about machine tool, it is, let's say, a guideway or a ball screw, and following that, how it varies over time. I mean, the performance of that system through, let's say, wear and degradation of a surface.
Yeah, that's we actually address some issues correlated to the friction. When more than 24% of the energy is lost just friction in the machinery and globally, which means we lost a lot of energy and money, and we impact very much environment. So therefore, we identify this problem and we try to functionalize the surfaces by creating a special texture on it. This can help us to save energy, save money, definitely can reduce CO2 emission, and it's very much connected not only to the machinery itself as for example, automotive industry, but also to the machinery that is producing the components. And we right now working on possibilities to implement these parts to the maintenance, because this is the part when the surfaces on the joints, and previously mentioned, can play a huge role. So the functionalization of the surfaces is something that working. It can be done different ways, utilizing the subtractive additive manufacturing, but also by special coatings and so on. So we collaborate in different fields around the surfaces, because it's not only how we produce them, but also how we evaluate them. And nowadays we have more than 300 parameters. So when we talk about the parameters, then we will see, oh damn, there's so many. So which should we should take into consideration while evaluating them? So we are working also on that field. And in this area, we very much collaborate, and we are starting collaboration on different algorithms that can help us, because we as a human cannot comprehend more than 7 parameters and try to remember several phone numbers, and you will see how it works. So therefore, I think it's very important to utilize the modern technology to support us with it also comes to decision making again, right? So which parameters to choose to evaluate. It's everywhere. It's a small decision or big decision, always there. So
yeah, and talking about surface, most of the failures happens on the surface in the surface level, and as one of our goal is to identify failures as early as possible. That means that we try to catch as small as surface changes as possible.
Yeah.
So I hate surfaces. they make my work so hard. So for example, from my field, it's when I look into how a machine tool behaves, like a production system, we know that most of the weird stuff happens in the joints, and this is connected to all these surfaces. So this is a huge uncertainty for my work, and I'm glad that we have this knowledge in the team helping me out. But for example, to give maybe an example impact of what we do here is we work together with the automotive industry to find process parameters beforehand and machine those very complex parts first time right. And of course, that's a huge impact also economically speaking, but not just, also ecologically. Because we can save a lot of material by not, having to manufacture a lot of parts beforehand. So I think in that sense, we all contribute, not just like money-wise, but also to the environment, which I like. It's good to work in such an environment.
I would actually like to give a reflection of what we discussed right now. We started talking about projects, and then I realized that we almost never work in research project without the involvement of manufacturing companies. And that's a very key point, I think. Because the problems that we work with, the solutions that we develop, and the methods and approaches that we develop along the way are very much in line with real world problems that the industries face today and in the future as well. So the results that we produce, I think, are highly applicable and very much useful for companies if they choose to implement it. And this is where the research that we do in this group is super, super important and useful. So this, of course, connects to not just measuring things for as a KPI for sustainability or money, as a matter of fact, but it's really applicable for manufacturing companies.
Yeah, I mean, also if you connect it to like sustainability goals as well, we know that there is a very good focus now on relating all the actions we are doing towards the United Nations sustainability goals. And talking about machine learning and that type of very computational intensive application, that could be an issue when we talk about, let's say, sustainability goal number 13, that are the climate. If we want to have a broad, implementation of those types of approaches, then maybe the computational power will increase a lot, and that will also consume a lot of energy. We see all these big databases now that have a lot of computers connected to them. So going back to what we discussed before the break, connecting this to the physics, and that is the approach we have chosen, we have high hopes to make more efficient computation where this could be addressed as a good output as well. And that this is a promising result we have seen so far in the research we are doing. So I think connecting everything we are doing through those sustainability aspects is very important from that perspective as well.
This is great. This is big part of Industry 4.0 that we are right now. When we connect the sensors, machines, algorithms, computational power, just to deliver more, better products. But just around the corner is Industry 5.0, when actually the center is the human. When we don't think any longer that the robot needs to do everything, when decision making is just supporting the operator in decision taking on the machine floor. Because many of these decisions are so complex that cannot be taken just by the computer or by robot. Therefore, I think we as a team, we address that too, because we see this possibility and these challenges ahead. Because we partly Industry 4.0 still very, very baby steps there we are doing, because we collect a lot of the data. Companies are doing that. They're part of our projects, but they don't know what to do with the data. And so they collect them because in case.
And then ask you to do some magic.
Do some magic here, yes. Yeah. And we try to understand the data, and then magic disappear because the data is wrong, for example, and we have to replan it, redo it. And that's a very big part of the actually collecting the data is the planning them. Can you say something more about this?
Planning is about taking into account domain knowledge, which we were also already discussed about in the first part. Which data to collect, where to place the sensor, which type of sensor. Should you collect vibration signal, acoustic data, or something else?
So, but I would like to share like a little anecdote. What I found during my literature reviews is like in production engineering, we kind of repeat ourselves. Like when people hear Industry 4.0, if I talk to industry, sometimes they roll with their eyes. And I mean, the human-centered production was in the 80s already tried and failed. And all this idea with a lot of sensors, where in case of like holons, they are called, also failed. They're not here in the industry. But I think just to remove all those eye rollers in the audience, the difference to the 80s and now is that we now really have the computational power which we would need. If we would have them in the 80s, we would have Industry 4.0 already in the 80s. But now we have the internet. Now we have 5G around the corner. And now we can actually, first time in human history, do like those paradigms, realize them.
And the miniaturization of the ships and so on as well. So we can embed it. Yeah.
Think about Moore's law. Now we have the power directly in edge computers. So I just want to make sure that we can't see you, but I guess you would roll your eyes if you hear Industry 4.0 again. But no, it's not a buzzword anymore. It's actually really here, and we're working towards that.
I want to paint a picture actually of a real situation in the future, hopefully already soon, of how it would look like to work in a manufacturing company. based on what you all described. It's not going to be chaos in the shop floor, in the factory, where people running around putting down fires. That might be the case a few decades ago, maybe even a few years ago. But in the future, if not already today, the maintenance planner or the production engineer, whoever it is, when they're on the way to job, they already have the things that they have to do today already in their mobile phones, connected with the machines, connected with the production plants, connected with the maintenance management system, connected with the logistics and everything. So this person, when they go into work, they don't have to be worried about what kind of problem solving do I have to do that is really, really urgent, but rather focus on prioritizing the most important work, which is already developed by, which is already calculated by this app, let's say. And then they go on in doing their day-to-day work, decision making mostly. And then the production is running as smooth as possible and as productive as possible. This is my dream scenario.
Yeah, sounds really good.
And I mean, we already see today example of some activities. We are working with other partners collaborating in projects where we have started to come with solution to this, towards this approach as well. So not even knowing what they are doing, they are already on the way to the system before actually the system have stopped. And they know what to do to bring it up again. But they cannot prevent it because it's physics, what happens, that the machine stops, for instance, or the production equipment stops. But they know what to do to get it up as quick as possible, so to speak. And I think here is really where the impact comes. Having that type of solution in your pocket or whatever will make a lot of, saving money for companies, not only monetary money, but also resources. And having a better understanding of the uncertainty of system and their behavior. And that will make things much more sustainable as well, because then you can have more kind of leaner organization, but still high throughput applications in your industrial environment.
I would like to add to this understanding what to do part. As I told before, that the work of the data scientist, of the analyst starts before actually getting the data. But I would like to say that the work of the domain expert doesn't stop when the data is collected. It's also the domain knowledge expert should always support the analytics part in order to interpret the results as well. It's not the number what we're predicting. We're predicting something what have physical meaning.
Yeah, exactly. I think it's what you said both right now is giving me thought about one research that is happening in the team is a self-check of the health of the machine tools. When a sensor-based system can monitor a machine tool and machine can adjust errors by themselves, which is already sort of like a magic. For some science fiction, but we aim for that. We aim for cars who are running and they're self-checking that. Listen, this will be probably something happening with your component. Check it soon. So we are expecting that the self-check system will appear more and more in the systematic way. So it will be not only that is inclusive for some manufacturing systems, but also globally that will be accessible.
Exactly. Yeah, and I think here, connecting to that, what we are working on also at this moment is to see how those applications could be more robust as well. And that's something that we have discussed quite much, Bernd, you and I, and the rest of the team as well. And I think we have this physics-based approach where we combine the physics with the data in order to get a better robustness in the system as well. And I think that's a key element here as well, connecting to these things.
Yeah, I think we find ourselves like in this unique point in time where sustainability is for the first time like a viable business model somehow. So by employing those ideas of low uncertainty or robustness, which might be not so interesting on their own maybe 20 years ago, nowadays we have really a chance to deploy those systems. And this is, I think, like I'm really lucky to be here, so to say, exactly now here at KTH and this team because of that.
it can be easily transferred to the value right now. We can calculate the costs and loss that not applying sustainability approach can cost.
But also sustainability is allowed to cost something.
Absolutely, absolutely. It can cost something and absolutely must cost something. And when we see the projects that we have, what you said, Mahesh, was about how industry is involved in the project. It's super important to mention also that this is industry-driven problem solving also, because it's not like we are sitting in the corners and thinking about the project, we invent something. That's happening also, but it's a big part is that is the society industry-driven. And we see the needs and want to, contribute to the better world. And that is the shift in the mindset, because the industry is also seeing the sustainability like a main approach. And by that also can approach the climate changes. And that is what we are connected with industry, which is, I think, found very nice.
Yeah, and we covered a lot of information about the projects, but we also try to teach our new generation to know all these approaches which we are working with. And we are...
To embed it in education from starting, that's very important.
We have one course about industrial analytics as well, right? I mentioned about decision making, but this is not only one part that we are doing. The new courses, one is industrial analytics. Can you say some more about this?
Yeah, so we have in the planning to develop at least one more course, more on advanced level course on that topic, to connect the domain knowledge with data science, basically, and by that taking a step forward as well. So the next generation of engineers coming out already from beginning have this mindset embedded. Of course, with also their own tweaking and understanding of the topic as well. That's so important for this.
Exactly. Data science is not a knowledge that is only within computer science students or IT students. It is a requirement on all walks of life nowadays, especially for manufacturing companies. So we teaching our students data science is a key impact as well for the society in general and for the Swedish manufacturing companies, where these students will go on and work in these companies, where these students will take over in the future about these data that's already available and making it into more useful information for the companies.
I don't know about any unemployment amongst our students, actually. So there's actually a big need. And also maybe to give some insights on how the research is working in Sweden is usually also driven by in-kind. So industry is not just interesting in the results, but actually contributing with real money to what we do. So that also shows the importance.
Not only we have no unemployed students, but we know that there is a huge need in more students for the companies in this field. So it's a very nice
bright future.
Yes.
And we're not even talking about just big companies. We're also talking about smaller companies, SMEs. They also work with data nowadays. They also work with prediction of things, planning things in advance.
This is work transition. So it's not only exclusively for the big companies.
So we really see the transition happening right now in all walks of life, including SMEs and big companies in manufacturing.
This was an interesting discussion, but unfortunately we have to round off. Andreas, do you have any final words?
Yeah, I think I agree with you. Very interesting discussion here, and I think the final remark from I is that we see that all the things we talked about, they are tools that we can use when they are appropriate to be used to have a more brighter future, a more sustainable future. That's, I think, it's the overall goal that we all have to work on towards more. And I think if you guys are interested to join, please contact any of us and we take it from here.
Yeah. Thank you very much. Lastly, I wish you all a great Science Week. Stay curious.
Det var väl ett jättebra slutord, stay curious.
Ja.
Eller hur, Monica? Du, jag tänkte på det. Du och jag har haft förmånen att vara med i massa olika intressanta samtal. Men vi har inte haft tid att prata så här med varandra.
Nej.
Men nu!
Yes.
Och då är jag ju nyfiken vad du har fångat upp här under dagen. Jag kan säga att jag har hamnat i vissa diskussioner där man ibland undrar, men vänta nu, bor vi på samma planet? För man har väldigt olika perspektiv och sense of urgency, om man får vara lite fräck och säga.
Mm. Jag hoppas ju att vi bor på samma planet.
Ja.
Men jag tänker att vi har i alla fall inga klimatförnekare. Det har vi inte stött på. Ja. Så generellt, jag menar, vi håller på att förflytta oss rejält. Idag finns ju verkligen insikten, tror jag, och awareness, som man brukar säga, att det är på riktigt, det händer nu. Vi pratar om 1,5 graders målet och hur nära det är dit. Men givet hur nära det är dit, så håller jag med om att vi har inte det krismedvetandet och inte att det går så fort som det borde. Men det är ju väldigt optimism, eller hur? Det har vi hört idag.
Absolut.
Alltså det är positivt, det är otroligt mycket saker som händer. Stora bolag som små bolag, olika branscher. Vi hörde ju livsmedelsbranschen.
Ja, men där sa de faktiskt lite olika saker. Där det framkom just att innovationerna när det gäller mat kommer från de små företagen, inte de stora. Och där blev det ju lite diskrepans vad man ska satsa på för resurser och så vidare. Och så akademin då, samma sak där inom livsmedelsbranschen. Håller på med jättespännande saker, men de kommer inte ut med det. Så vi hamnar lite grann i samma diskussioner om att det handlar om kommunikation och att komma ut med allt bra som man sitter och funderar på. Känner du igen det, eller?
Ja, och det finns ju en del saker som pågår just nu när det gäller att små startups ska göra affärer med stora bolag och sen kanske också producera i Sverige. Så där finns det ju saker på gång. Men det är klart att man måste fånga den här entreprenörskapsförmågan och innovationsförmågan och produkterna in i de stora också. Och någon slags växelverkan. Kan man ju fundera, klarar man av det själv som startup och stort bolag? Är storbolagen liksom beredda, eller måste det till något innovationssystemet? Det kanske är att det behövs en liten knuff ibland.
Sen var det också intressant att höra nu när man av olika skäl, pandemier och så vidare, har ju gjort att det har blivit ännu mer aktuellt att tänka på produktioner där man bor. Och då får man ju känslan av, wow, nu kommer pengarna tillbaks till Sverige. Då kan vi väl göra ännu mer roliga saker.
Nej, men det är faktiskt en sån här liten trendspaning som vi känner lite grann. Alltså dels de bolagen som kanske har sina försörjningskedjor och kanske har mycket material, kommer från Kina eller andra länder. Vi ser hur sårbart det är. Man flyttar hem, eller att man har åtminstone dubbla leverantörer så att man säkrar av något lokalt. Så tror jag det är. Men det är också så att Sverige idag, tack vare framförallt vår energiförsörjning, också lite hur vi jobbar, börjar vara hållbar. Så jag tror att hållbar produktion också kanske är den faktor som kan, eller hållbarhet kanske är den faktor som börjar driva produktionen tillbaka. Alltså att om kostnaden drev ut produktionen för 15-20 år sedan, så kanske hållbarheten tar den tillbaka. Och jag tror också att, eller det är väl ganska uppenbart att verkar du på en marknad, då vill du också ha din försörjning där. Så jag menar,
såklart.
Ja, eller hur? Det är inte så jättekonstigt. Verkar du på Europamarknaden som vi gör, då vill du kanske ha din materialförsörjning helst på Europamarknaden.
Och sen är det de sakerna som kom fram när vi hade den här diskussionen på morgonen om hur vi ska fortsätta vara attraktiva. Och jag kan ju erkänna att jag hade inte riktigt den uppfattningen att vi var nummer 2 som det mest innovativa landet, som Jim Fox från AstraZeneca sa. Men å andra sidan så beror det lite grann på vilka listor man läser. Och det skrattade ni ju alla åt, så att, vad är sanningen här då?
Ja, nej, men vi toppar ju ofta, eller ligger liksom på topp 3 eller topp 5 när det gäller innovationslistan, och hur man mäter det vet jag inte. Men det är klart att vi för att vara 10 miljoner så tycker jag...
Så är vi rätt duktiga?
Ja, men jag tycker att vi kan säga att vi är ganska duktiga. Titta på vilka framgångsrika internationella bolag vi har. Bara det på 10 miljoner. Och så sen vilken startup-scen vi har. Det vi ser nu också som vi vill jobba med lite grann är ju att också jobba med startup-bolagen och se till att de producerar i Sverige. Det är nästa steg. Så att vi får liksom ett flöde av startups som också växer och blir stora producerande bolag. Och nu pratar jag alltså om de som har fysiska produkter. Många startups idag har ju liksom mera... Det kan vara på tech va?
Men du betonar ju också, ja, vi är duktiga, men vi ska också inse att vi har en stor konkurrens från resten av världen. Och då kommer vi genast in på det som faktiskt ofta dyker upp. Hur behåller vi kompetensen i Sverige och hur lockar vi till ännu mer kompetens i Sverige? Och vi var ju nere på förskolenivå nästan när vi pratade om vad är attraktivt för någon att komma hit. Vad säger du?
Nej, men vi jobbar på flera leddar här. Alltså dels har vi ju att utbilda våra egna och få dem också in i vårt fall i industrin. Alltså alla skriker ju idag efter kompetent arbetskraft och det gäller inte minst industrin. Men sen här är ju, vilka kan vi locka utifrån hit i Sverige. Och Jim Fox var ju en bra ambassadör får man ju säga. Fler som han så kommer ju väldigt många till Sverige. Alltså att vi har liksom, det är ett bra land att bo i om man tittar på en helhet.
Så vidrör den också som kan vara lite känsligt kanske, den här fighten, men lite konkurrenssituationen mellan Stockholm och Södertälje. Och där det framkommer att man kanske ska samverka mer och inse att den ena staden finns till för vad den finns till för och Södertälje för sitt, så att man samverkar även i det.
Ja, men jag tänker, det finns väl inget annat liksom att göra än att Stockholm är faktiskt huvudstaden. Där finns också mycket, vi har ju mycket huvudkontor och mycket forskningscentrum. Vi har managementkonsulter som också påverkar mycket på strategisk nivå. Men Södertälje är ju en enorm power i den här stan som man inte kanske hela Sverige känner till. Att det är ju, Scania och Astra bara har ju kanske totalt 23 till 25 000 anställda.
Precis, och det var bra du nämnde dem, för vi ska alldeles strax besöka både Scania och AstraZeneca. Men jag vill tacka för att du var med idag, Monica. Vi ses ju fler gånger.
Ja,
och framförallt så ska ni ju vara lyhörda över det som händer imorgon. Men först det här.